I'm Akshata Kulkarni. Today I'm going to give a presentation on Elasecutor scheduling in data analytics system. Authors of this article are Dr. Libin and Dr. Hung, and this article is extracted from the 2018 conference. So let's moving to the presentation. Here we can get to know what does the problematic statement says. Basically, modern data analytics systems use long running executors to run an application, and these executors exhibit time varying resource requirements. Existing schedulers simply reserve resources for executors and use the peak resource demand to guide executor placement. See here what it leads to: the higher workloads, and which lowers the performance. Basically, here it says that various workload running in data analytics system concurrently lowers the performance. It means that more the load, less the performance. So how can it be resolved? We need good performance. Also we need to think on the point of workload should be less and performance should be high. So let's come study what best can we give for the solution approach. So here what does it says: instead of placing executors using their peak demand, we can approach one more method, that is called dominant. The name itself says dominant, which which utilizes the remaining resource to minimize resource fragmentation. It means that using less resource fragmentation giving the good performance for the machine. And this is possible to develop a general executor scheduler based on Elasecutor, so which can be integrated into yarn and other cluster schedulers and other executor based system. What is a new approach has been implemented for this study? The study has been conducted using 35 node cluster, which means it is Spark based prototype implementation, and the executor reduces more than 42% on an average and reduces median application using time up to 40%. So here we have used 35 node cluster, which is a Spark based prototype, and Elasecutor reduces mix span by 42%, so which improves the utilization by 55%. So less the workload, more the performance. So, and this Elasecutor builds on how does it works. See, we have discussed in the problem statement to minimize the workload and to make the performance better. So how does it work? This Elasecutor builds on two ideas, that is either allocating resources or placing executors strategically using the minimal resources. So coming to the detailed study of this article, that is these executors utilizes CPU, memory, network, etc, which exploits the recurring nature of many applications in productions and predicts the resource demands of application over its lifetime. Elasecutor elastically allocates resources to executor according to the predicted time series of demands in order to reduce underutilization. So this is how the Elasecutor come into picture, that it utilizes less resources and gives the more performance. So which is what said here in the schematic representation. Schematic representation says about the elastic executors as well as the dynamic scheduler. It means basically the performance of the elastic executor and the performance of the dynamic scheduler, which we have seen in the problematic statement. And we can look after to one more schematic representation where it says elasticity based on the key space repartitioning and elasticity based on the core assignment. See here, which is overloaded, this is the core, or you can say the key, which is overloaded, and if it is imposed on a system, how does the machine work. And here we can see the core. Here there is a key, the core which is overloaded here, and the performance of the system we can, or the performance of the machine we can see. So these two are the schematic representation of the system. So coming to the scope of improvement, how best we can improvise the system. So the executor what we are using is, it allocates time varying resources to executors and assign them to machines based on the predicted demand or a time series. So when this series best matches the time series of a machine available resources, executor also reprovisions resource dynamically. Basically, this allocated, whatever the allocated executor should match with the other series of executor, so to give a better performance. These experiments with real workload shows that Elasecutor substantially improves the performance, as we seen in the previous slide, saying this Elasecutor, it shown the better performance where the workload is less and the performance is better. This is what it says, that experiments with real workload show that Elasecutor substantially improves performance when compared to the existing solution. So coming to the this is what the article and the study means, and the reference links, these are the links from where I have referred about this elasticity, elastic executors, and this about this study. So yes, this is all about my present.